Generator connection accessories. Grounding transformer cubicle. Introduction. In large power stations, the generators are connected to the generator transformer by an isolated phase bus. A generator circuit breaker may be installed between the generator and the generator transformer based on economic consideration or ease of operation. In captive power plants with smaller unit sizes, the generators can be connected directly to a circuit breaker of a distribution board. In a generator connection, a situation may arise when the generator circuit breaker is open and the generator transformer high voltage side circuit breaker is in closed condition to feed the generator auxiliaries. This can happen when the generator is taken out for routine maintenance or for a fault in that zone. Under that condition, a section of the isolated phase bus connecting the generator circuit breaker to generator transformer with a tap-off to the unit auxiliary transformer remains ungrounded. This section is identified between the location 1, 2, and 3. Depending upon the unit size, the generator transformers may consist of 3 single-phase transformers connected in delta. The generator transformer LV winding and unit auxiliary transformers high voltage winding are connected in delta. A voltage transformer is required to be installed in this section of the connection for the purpose of synchronization. Notwithstanding the above, it is grounded by the capacitance of the main and tap-off bus, the capacitance of the low-voltage windings of the generator transformer, and the high-voltage winding of the unit auxiliary transformer. If voltage transformers, surge arresters, and surge capacitors are separately installed in a surge protection voltage transformer cubicle on the generator transformer side of the generator circuit breaker, then their capacitances to ground also need to be considered. This combined capacitance of this section and inductance of the transformer coils in parallel will have a specific resonant frequency. The voltage across this tank circuit will be contained by the resistance across it to dissipate the energy. The circuit will still resonate but with a much reduced magnitude of voltage. An arcing fault on a delta winding will produce a broad spectrum of frequencies of varying amplitude. One of these may correspond to the resonant frequency of the tank circuit. This phenomenon is referred to as ferro-resonance. There are several ways to clamp the voltage of this ungrounded section of the isolated phase busbar. These include installation of zigzag grounding transformer, Y-delta grounding transformer, open delta grounding transformer with resistor. Any equipment installed in the generator connection must be highly reliable and it should be ensured that the probability of the occurrence of a phase-to-phase fault is minimal. Consequently, each phase of the grounding device must preferably be separately accommodated in a housing and the secondary connections are made externally. This will eliminate phase-to-phase fault in the generator connection. This is not practical in case of a zigzag transformer. Single-phase transformers can be installed in individual compartments of the surge protection voltage transformer cubicle and the resistor can be installed in a separate compartment in the middle phase. Zigzag grounding transformer. A zigzag grounding transformer has 6 windings with 2 winding on each of the 3 limbs of the core-type construction. The line terminals are connected to the generator connection. The phases of a zigzag transformer cannot be separated and has to be installed in a single cubicle as a 3-phase unit. The sizing of the transformer can be carried out based on the reactive volt-amperes of the capacitance to the ungrounded section of the connection. An optional grounding resistance may be installed to limit the ground fault current. As mentioned earlier, any equipment that is connected to the 3 phases of an isolated phase bus must ensure a reliable connection with the negligible probability of a phase-to-phase fault. It is therefore suited to be installed for smaller unit ratings connected to a 3-phase generator circuit breaker. Y-delta grounding transformer. Single-phase transformers with shell-type construction can be installed in individual compartments of the surge protection voltage transformer cubicle when separately installed. The line terminal of the primary winding is connected to the tap-off bus and the neutral terminal is connected to the earth in each of the cubicle. The low-voltage windings are externally connected to form a closed delta connection to provide path for the zero-sequence current to flow. The sizing of the transformer can be carried out to provide the reactive volt-amperes of the capacitance to the ungrounded path. Open delta grounding transformer. Single-phase transformers with shell-type construction can be installed in individual compartments of the surge protection voltage transformer cubicle when separately installed. The line terminal of the primary winding is connected to the tap-off bus and the neutral terminal is connected to the earth in each of the cubicle. The low-voltage windings are externally connected to form an open delta connection to provide path for the zero-sequence current to flow through the resistor. The resistor bank can be installed in the middle phase of the surge protection voltage transformer cubicle. The sizing of the transformer and the resistor can be carried out by equating the losses in the resistance to the charging reactive volt-amperes of the capacitance of the ungrounded path. Thank you. For a comprehensive understanding of the theory and practices of busbar systems, it is advisable to read the book An Introduction to Busbar Systems, where contents are organized in a sequence for ease of reading and facilitates cross-reference. Please procure a copy of the book with a requisition to bala@busbarsystems.net.